Okay, guys, so hopefully you finished solving this problem. So, and as you can tell, I did fix the mistake. But okay, so what did you guys get? So let's repeat it. So in a math class of 30 students, 17 are boys and 13 are girls. On a test, 4 boys and 5 girls got an A. What is the probability of choosing a girl or an A student? Now, what a lot of students tend to do when they do look at this problem, they try to use this rule. So they try to go, so hold on just 1 second. They try to use this disjoint rule, right? They try to do this problem. Okay, they try to say, okay, well, I'm just looking for they want to say, well, I'm looking for the probability of getting a girl, or the probability of getting an A student, right? So what they do this entire thing, right? They try to use this formula, right, to solve for this. So all they just do is add the probability of girls and add the probability of A students, right? Well, if you look back in the problem, right, the probability of getting a girl was 13 out of the 30, right? And the probability of getting an A student was 9 out of the 30, right? And in the end, right, when you end up adding these numbers together, what you end up getting is 22 out of 30. So you would think that this is the answer, but nope, that is not the answer. Why is that not the answer? Well, that's because you're kind of counting the girls twice, right? You're counting the girl, because there are some girls that also got an A, right? So you are double counting here. So you have to get rid of that, right? So in addition to that, remember, this formula can only be used if two events are disjoint, right? If A and B are disjoint, then you can go ahead and use this formula. In this case, girl and an A student are not disjoint, right? They are not disjoint because there were some A students that were girls. So we have to think of something else to do. Okay, so what exactly can we do in this case? All right, now let's go back to the question. Okay, so let me go ahead and get out of here, right? So the question here was, we want to choose what is the probability of choosing a girl or an A student. Okay, so let's try to figure that out. Okay, so this is how I'm going to go ahead and do it. I'm going to go ahead and use, not that. I'm going to use this. Okay, let me go ahead and write it and see how this works out. So right now I have, oh, I am in the wrong one. I have my sample space. Here is my sample space. Right? Here are maybe girls. Here are A students. Okay, let me go ahead and make this a little bit better because I actually don't like how I wrote this down. Oh my goodness. What does this do? I think this helps out a little better. Okay, so let me write it really big. I actually want to write it really, really big. Okay, so let's say this is going to be girls, right? This is girls. Okay, this is girls. And I'm going to choose blue for A students because those are the two events that I'm looking at. Okay, I'm looking for girls and I'm looking at for A students. Okay, so this is my sample space. So essentially what I want to figure out is I want to figure out the probability of getting girls, G stands for girls, or an A student. That's what I want, right? So if I were to go ahead and shade that area in this Venn diagram, basically the area that would be shaded is everything that's here, everything here, everything that's an A student, everything that's an A, and everything that's in both. Because that's what we said in the previous video. In the previous video, A or B is all of this, right? Everything that I'm shading. That is what I want, right? The yellow area is what I want. Okay, so how am I going to find this? Okay, so let's try to think. I'm going to go ahead and write it one more time. I'm going to get another one of mine. Sample spaces. So here is girl, here is A student, okay? And what I want is a probability of girl or A student. Okay, that's what I want. Okay, well, this is gonna be my reference, right? I want this. This is what I want. Now, how am I gonna get that? Well, I'm gonna use this thing this one right here, to try to get that. Okay, well, one thing that I can go ahead and do is I'm going to add up all the girls. Okay, so I'm going to add up all these girls. Okay, I'm going to add them all up. Okay, so when I add up all the girls, all of these are girls. Okay, I'm just adding up all that Venn diagram. I'm going to add probability of girls. Okay, that's what I did. I'm going to add up all the girls. I'm not there yet. I'm not where I want to be. I'm not where all the yellow part is. So right now I just have probability of girls. So I just need to add this part. So what I'm going to do is now I'm going to add up the probability of all the A students. Okay, all the A students, all the blue one. I'm going to add up all this blue. Okay, so this is all the A students. Uh-oh, but what did I do when I added the probability of all the A students? Okay, when I added the probability of all the A students, which is basically what we were doing in the piece of paper, right? What we were doing over here. Let me go ahead and show you guys what we were doing right here, right? What we were doing here. This is basically what we're doing in the whiteboard right now, right? Right now, what we have is all of this, right? That's not what we want, because when we add these two together, what do we get? We ended up adding the middle piece twice. So how do we go ahead and compensate with that? Well, what I'm going to do is I'm going to subtract one of the middle pieces. And one of the middle pieces, right, if you remember, the middle piece is what we called intersection, right? The intersection, the A and B. So I'm going to subtract the probability of getting a girl and an A student. Exactly. That is going to give me the probability of girl or an A student. So that's what I want to figure out. So for all my visual learners, this is how you kind of see it visually. This is where the formula comes from, and I'll show you what the formula is. Okay, so now let's figure it out. So the probability of getting a girl. Okay, so let's go back to the problem. What is the probability of getting a girl? Okay, I'm not going to go back and forth, but if you go in the PowerPoint, right, how many girls are there? There's 13 girls out of the 30, right? So this is just 13 out of the 30. Okay, I thought I put black. Okay, whatever. All right, plus the probability of getting an A student. Okay, well, how many students got an A? Do I care what their gender was? No, it didn't say anything, right? So probability of getting an A student is just, well, there was 4 boys and 5 girls that got an A. So that's a total of 9. 9 out of 30. Okay? Minus the probability of getting a girl and an A student. So how many girls got an A? So that's a total of 5. So that's 5 out of 30. Okay? Okay, so then after I have that, I'm going to go into my calculator, right? And add and subtract. Add the 9 and subtract the 5, and what I'm going to get is 17 out of 30. That is my answer. So the probability of getting a girl or an A student is 17 out of 30. If you got that at the very beginning, you should be very proud of yourself. And if you didn't, it's okay. It's not the end of the world. We're just still learning. Now, what this is actually called the addition rule. Okay, so let me go back to my little document over here so that you guys can all see. So what we just figured out, this is a new formula. This is what we call the addition rule. Oops. Addition rule. And the addition rule states that the probability of A or B equals to the probability of A plus the probability of B minus the probability of A and B. That is what the addition rule states. Okay. Notice that the addition rule is very similar to the disjoint rule. The only thing that's different is that you have this minus portion of A and B. If I got rid of that, I still have the disjoint rule. Now, notice also that this formula works for everything, even if it's disjoint, because what happens here? If I have the probability of A and B, well, we know that the probability of A and B, if two events are disjoint, is equal to 0, right? So this goes to 0, and we're just back to the formula that we had before. So worst comes to worst, just use this formula, right? You just have to keep track of when disjoint events occur, right? So this is what you really have to be watching out for. So that's basically what the addition rule is. So we're going to be doing some problems in class about this particular rule, right? And yeah, okay. So if you have any questions, just let me know. I think this is going to be the end of this video now. All right.